Welcome, everybody. I'm here to talk about, clearly, Introduction to AWS Serverless Architecture. It's a very intro-level talk, like I just said. My name is Usha Suryadevara. I'm a Director of Development at Infotech. Well, great start. All right. I am also the founder of an organization called WAT. It's for women in tech. It's an initiative for women in tech. So who is Infotech? Infotech is a company based off of Gainesville. We've been around for 40 plus years. And we have been and will continue to solve problems for contractors and Department of Transportations by automating their pain points. It's the best way I can explain this. So for example, if you're going on a highway and you guys see construction, there's a really good chance they're using our software for it, maintaining the project. I've been with Infotech for 17 years now. And over the 17 years, I have seen us transition from one tech to another. When I started, we were in the process of moving away from mainframes towards client-server architecture, which was good. And we, at the time, were maintaining servers in-house. So we had to deal with different type of issues, like, is there a security pad on the door? Do you have a security camera there? Like space, environmental type issues. You have to maintain the temperature at a certain point in the server room. Not everybody can get access. And because we were in a really old building, there was sometimes it used to rain in the server room. We had water pipes going over and, yes, exactly. So we didn't want to deal with any of that, so we decided to move to a data center. So we were in the data center for quite some time. And then we found ourselves having to drive to the data center. We're in Gainesville, but our data center was in Atlanta and then in Miami. Regardless, it's a good 6-7 hour drive. So at one point, we had way too many customers, or we had to beef up our servers. So we had to go purchase our hardware, drive over, go there, do it physically, which is still fine. We can still plan for that aspect. Production issues. At one point, we had to restart our server. So we were like, oh, let me find the IT. Let me put a ticket in here. Wait, let me call the data center. Oh, wait, did you find our server rack yet? Please restart it. By now, we were down for 10 minutes, and that was not acceptable for us at all. So then we decided, okay, you know what? Let's just go to cloud. So then we moved all in Amazon. We still use our EC2 servers. It worked out great because now this is infrastructure as a code. All we have to do to set up a server is open a wizard, pick different configuration, next, I'm live. Oh wait, I need to beef up my server. Oh, no worries, right click, increase my memory, restart, done. It's been great. We still have to maintain our product updates, we still have to do the security patches, we still have to upgrade, if it's a Ruby on Rails server, maintain the version of Ruby, Rails, and whatnot. By now, we're really spoiled, we didn't want to deal with even that. And then serverless came along. So this is, I think, personally, the final layer of abstraction that can happen to cloud computing. The unit of scale at this point is a function. All you have to do is code that application logic in the function and you are good. It's independently deployable, you can iterate rapidly, it's polyglot friendly. If you have multiple functions for your apps, it's okay that one is in Python, it's okay that one is in C#. It's a good developer experience. They can pick what they want. Oh, that's a bad quality picture. It looks fine works on my machine. But that's not true. When you run your function, it has to run on a server somewhere. What serverless means is you yourself are not responsible for provisioning it. You're not responsible for managing the servers at any cost. Someone else is doing it for you. So all you would do, like I said, is upload your code to your function as a service provider, and you're live. Here's some popular serverless tech. AWS Lambda is on the top of my list for 2 reasons. One, it has 70% of the serverless market share, so it's very hard to ignore. And 2, I don't know anything about any of the other ones. So, why use serverless? I already talked about self-managed aspect, and I know we heard Sean yesterday talk about some of these as well. It's super scalable, and you only pay for what you use. You don't pay for the idle time at all. It's event-driven, as in something external has to kick off the entire thing. And security advantages, you don't have to worry that much about security because guess what? When your code's getting executed, you're creating a brand new environment. And then once it's done, it's all gone. Your compute resources are garbage collected. So there is no persistent, there is no state. Could also be a disadvantage, but let's go with advantages for now. So how would you use serverless? Before we go into this, I want to go over some of the core, if I can call them core, services that AWS has, because we'll be using these in our examples going forward. So S3 is their simple storage service, provides file storage. And anything in AWS, all the services have triggers all over the place. So even if I don't talk about it, it has a trigger. So for example, a file insert into S3, you can trigger a different event. You can configure it to do something else on an insert, on a delete, on any of the CRUD operations. And you can also host static websites. The funny thing is, maybe not funny, it's normal for simpler architectures where people are choosing S3 as a substitute for the database. As in, they're actually storing JSON objects in S3. And don't worry, I know you're from all DevOps, but you can encrypt S3. It's all secure. API gateway, think of it as a front door to your service. It defines the URLs. Lambda, the heart of serverless, function as a service. So the definition of serverless architecture that is focused around function as a service is pretty old. It came out in 2014 when Amazon released Lambda. Right now, the definition of serverless architecture looks like something different. It is just a composition of cloud services that you're combining to solve a problem. It's just a bunch of self-managed services. There's nothing more to it than that. It's as simple as that. In fact, you can have an entire serverless architecture without a Lambda. DynamoDB is Amazon's NoSQL database. It's actually more than document-based. I know I said document-based. It also does key-value pairs. It's amazing at scale. It scales really, really, really well. It is also a huge pain to use. You have to understand how DynamoDB works. You have to figure out what the access patterns need to look like before you start using it. Otherwise, halfway through, you're either migrating or looking for a different database. But guess what? There aren't any other serverless databases. There's one. Aurora just came out. But I didn't do any research, so I don't know how to compare. But for the longest time, DynamoDB was the only serverless database. And just like any other service, triggers and events, you could trigger a Lambda on an insert into a DynamoDB. It's very convenient. Some other services. I wrote them down like this instead of a previous format because I think Amazon went with a convention at one point on how they're naming their services. Email service sends emails. Queues units of work. And notification service basically publishes a topic for the event. CloudWatch, it's their monitoring and logging service, and you could actually configure some analytics on it, like CloudWatch metrics, to analyze your logs right then and there. And not just logs, even your monitoring stats that come from your servers. It's really handy. You can create dashboards. Kinesis is their service that makes it extremely easy to collect, process, and analyze video and data in real time, which means you can actually start analyzing data as it's coming in. You don't have to wait for it to be done. Okay, now let's go into how to really use serverless. So how would you put a serverless architecture together, an app together? First, you have to design the experience. This doesn't just apply to serverless, it applies to everything. Everything we do at Infotech. First thing we do is figure out what is it that the user is going to experience. What is the problem you're trying to solve? So the simplest case, I have a device and I have my site. Experience dictates the services. So I have a site, but I need to do something. I want to go click on a URL, which means I need an API gateway, because that's how we do URLs here. But I don't want to just click on a link. I want it to do something for me. So then I'll put a Lambda behind it, because Lambda is where I would actually put my logic. Let AWS do the heavy lifting. This was a hard lesson personally for me, because if I'm designing an architecture and I'm at a point where, oh, I need to send an email, my instinct for the longest time is, oh, let me go configure my email server, or let me go use that. But for us to actually, or for me to go and do research saying, oh, what other AWS services are already out there, and try to connect them, architect them, it was a decent step. So right here, I started with just my client having hosting a site in S3. I have a pointer. I don't know why I'm not using that. And then I figured, I have a link, so now I need to put some logic behind, so I have a Lambda. But wait, my Lambda can do a bunch of things. Let's say I need to maintain data in the database, so I do that. And then I was like, no, you know what? I need to just put a work in queue, queue a job, so I can do it later. So I can do that. I can do emails. I can do notifications. I can even talk to another Lambda, so I can kick off another Lambda. Or I can still go right to S3. Anything you want to do, there's definitely a service out there that AWS has. Some with weird names, but they still have it. So when would you use serverless? To me, and this is what I keep telling everybody at work as well, the most important thing about serverless is figuring out the use case. Serverless will work for anything and everything. You can make anything work, but is that really what you should be doing? What is the best practice here? So I've read a lot about serverless, and I came across a bunch of articles, and almost every single one of them talks about how it is amazing. It scales so well. So you should consider it when you have a requirement like that, where you need to scale to like hundreds of thousands of concurrent requests at a time, which is great. I mean, without any manual intervention, you're able to do that. And Amazon's able to do that for us, that architecture. But what about small workloads? What about infrequent? Serverless is also a really good candidate for that because of the on-demand compute space. And combine that with the actual concept where you're only paying for what you're using, it makes it a perfect candidate for it. So the rule we use at work is serverless is a really good candidate for anything where you have infrequent, spiky traffic that needs to scale, really scale, or just not scale at all, either way. So here's how some people use serverless: mobile backends, data processing, static websites, chatbots, video stream processing, crons. Netflix, that's how they started using it. They have a bunch of Lambdas, they're serverless, and all of them are crons. All right, we're gonna go over some patterns just so you guys can get an idea of how you could architect or possible examples. So this is a really simple pattern. This is almost like how you would start using serverless, going by the book, by the definition. You have a client, you're going through, and you have a Lambda that's doing all the logic, and it's being fronted with an API gateway. And let's say the Lambda needs to write some data to the DynamoDB database. So everything here is synchronous, which means the client's going to initiate the request. It's going to go through API to Lambda, to DynamoDB. It's going to do whatever it needs to, the interaction. And then the response is going to come all the way back to the client. So the client right now is waiting on everything. So that's synchronous. So anytime we have two arrows going back and forth, it's synchronous communication. So this is the internal API pattern. So when I say client, it could be anything. It could be a user, a browser. It could be another microservice. It could be another Lambda. It could be anything. This is serverless. It's like putting a bunch of Lego pieces together. So this is the internal API pattern. So this is, again, synchronous. And I don't know if you noticed, but we're actually missing an API gateway here. What that means is this should not be external. If it is, then you have huge security issues. Anytime your URL is live, it's better, you have to go through the API gateway. But right here, it could be just another, like a DynamoDB triggering a Lambda. It could be another Lambda triggering a Lambda. But this is going through AWS SDK using their HTTP API. This is not going through the web. It's internal to the AWS infrastructure, basically. And still synchronous. Internal handoff pattern. So this is more popular than the previous one. The difference being this is asynchronous communication, the other one was synchronous. You can do both with serverless, but you get all the benefits of serverless with asynchronous if you can design your entire experience with just handoffs, with just asynchronous communication. So basically the client is triggering the Lambda, and then it's done with it. It's going to make sure that the Lambda has been invoked, and then it goes on in its own way, whoever the client is again. So Lambda at this point, again, same thing, asynchronicity is like, hey, DynamoDB, do this for me, and it's done. It's not going to wait on whatever is happening. What that means is handling errors becomes extremely important at this point because the Lambda has, the client has handed off the execution to the Lambda. So how is the client going to know if this fails? So that's completely up to us. What AWS best practice dictates is you configure SQS. It's called a dead letter queue. So anytime there is a failure, it can basically just insert in the dead letter queue. And then it is again up to us to figure out how to monitor the queue. You can do it a few different ways. One of the things we do is just CloudWatch metrics, and we keep an eye on it, saying if there's more than 2 messages in the dead letter queue, notify me. And so the red arrow means an error. So this is, the Lambda just got invoked asynchronously, which means AWS's default retry mechanism is also kicking in. The queue has, AWS has policies that you can configure that basically dictates the permissions and authorization. So there's something called a redrive policy that you can configure on the dead letter queue right here, and that's going to control the duration of your retries or the number of retries. Continuous stream pattern. So this looks a little bit complex, but it's actually pretty straightforward. I have this because I want to show that you don't always have to have a Lambda. API doesn't always have to kick off a Lambda. It can actually kick off a bunch of other services. So in this case, the API gateway is just acting as a proxy for my Kinesis stream. So I'm just feeding a bunch of data, and then my Kinesis stream takes that entire stream and then just distributes it across my different Kinesis streams. And you can do some transformation. You can configure Kinesis to do some transformations and such. And then your Firehose, it's their service that you can use to ingest that data back into a different AWS service. So it's basically putting it back in S3 and then bulk loading everything into Redshift. Redshift is Amazon's data warehousing service. And anything can feed into Kinesis, by the way. It doesn't have to be API gateway. So I'm just using these as examples. Strangler pattern. So I like this pattern a lot. I think this makes the most sense to me because serverless is really new. Microservices concept is really new. People still look at them as buzzwords. But what if I want to try microservices? What if I want to actually put a serverless architecture together? How do I start? Because we still have had apps. These concepts are new. So they call them monoliths now, even though it's just layered architecture, just bad rep. So what if I have a legacy app, but I want to somehow, like what we are trying to do right now, take this entire app and we're trying to break it into multiple microservices. So this is the best way to do it, is still have your app run. So let's say my app is example.com. So my API gateway is still running that URL. But depending on what endpoint I'm trying to access, it knows to either kick off the microservice up there or just route the request to my legacy app. So eventually, when we're picking out pieces, there'll be a bunch of microservices, not just one. And then still, I can control the routing to my legacy app. So I can use everything in parallel. This makes more sense. This is more affordable because I don't think all companies can afford to just take a year and then rewrite a monolith to microservices. Aggregator pattern. So here, it's very similar to the simple pattern. The only thing the Lambda is doing is it's actually talking to a bunch of different microservices and waiting on the response and aggregating everything and then sending it back to the client. An example would be file-based or logging, basically. Yes?
Can we ask questions as you go along? Or should we?
Sure. I can blame you later if I lose my flow.
Awesome.
But what's the question?
If you go back one slide, I was interested in the concept of using the API gateway to split those for a legacy app. Have you also attempted basically, a few slides ago, you could do the legacy app to actually trigger the lambdas as well? So I was wondering what the pros and cons of actually having the gateway split the services compared to having all the legacy and then splitting the microservices out of the legacy app and then eventually getting.
So you're talking about the legacy app, instead of going this way, it's just directly kicking off my Lambda somewhere else?
Yeah. You showed that in a couple of slides.
You could do that. So the way we structured, it's definitely an option. It's definitely an acceptable pattern. But the way we structured our AWS accounts at work is the legacy app is in its own account, and my serverless apps are in different accounts. Because the way we're pulling these pieces out is they're reusable components. So other products can use the same thing as well.
So you have other servers that are picking up.
So for us to make that happen in a secure way, we have to create a VPC pairing. And we weren't ready. That wasn't a good enough reason for us to actually connect those two accounts that way. So that's why we chose to go through a API gateway. So it's going out through the web, treating it just like a different service.
Thank you.
Yeah, so we already went over that. State machine pattern. Yes, sorry.
Actually, you didn't finish the last slide. You said something about logging.
My bad.
My bad.
Oh, yes, I was, let's blame it on him, everybody. So I was trying to come up with an example as I was talking about this. So let's say billing scenario or something, right? I'm trying to figure out how much space my microservice, each of those microservices are using. So this one's basically just aggregating all the information for me. And then, so it's talking to microservice A, hey, what is your occupancy? Or to, hey, how much storage are you using? And then it's going to aggregate everything and just send it back to the client. I was just trying to come up with an example. Thank you, though. State machine pattern. State machines are awesome, especially when you have a bunch of tasks and you're trying to organize them. It helps a lot. It reduces your complexity immensely, actually. So AWS step function does exactly that for us. One more thing to remember. Anytime we have a Lambda is getting kicked off asynchronously, you're going to see this red arrow and the queue. I'm just not going to repeat it, but that's always, it has to be there. Otherwise, your design's incomplete, and you'll never know what failed where. So step function's really cool because it's going to take this entire complexity and make it super simple for you. So let's say you have a Lambda that has to do like 10 different things. It's so easy. It's like a flowchart, actually, the way you configure the state machine, that the step function that Amazon has. It does all the error handling for you. You don't have to worry about anything. But you can only use this if your entire design is asynchronously possible. Your experience has to be completely asynchronous. Step functions do not do synchronous processing. So it does your timeouts, it does your error handling, it does everything for you. But also racks up a nice bill. So when you actually have a limited number of tasks that you need to do, you're better off using a pattern like this, where you're manually doing it per se. So my Lambda here is either kicking off task A, B, or C, depending on whatever the main Lambda decides. And it's just simple microservice, so it's just writing to DynamoDB. It's not doing much. But this is essentially doing the exact same thing. It's more like a glorified switch statement. Robust API pattern. So this is a variation of their simple one again. It's doing a lot of things. And I wanted to show that anything is possible and you can connect any number of microservices, any pieces, anywhere. So this is the API gateway, is basically routing the request to Lambdas, all of them actually synchronously, and it's waiting on them to get back. The first one, however, is kicking off my microservice A. It's not going to worry about what's going to happen there. It's just kicking it off. And then synchronously writing to DynamoDB and whatnot. Fan out, fan in. This is actually the fanning out concept is basically very simple. It's just you're taking a huge workload and you're splitting it out into smaller workloads. So this Lambda just split its workload across 3 different workers. Of course, there's logic there. It needs to know to kick them off. It needs to know to distribute the work, so hence the term fanning out. And then the way you would, so you'll probably do something like your application logic would handle having like a task ID of some sort, and then each one still carries the task ID of the main one. So when you combine everything back, you're fanning everything in and writing to a data source, it knows that it came from that major workload, just to link it back. Distributed trigger pattern. So after this, remind me to talk about logging. I know I don't have a slide for it, but this is something just reminded me of that. So here, it's what I wanted to show is a pub sub type architecture where you're just publishing a topic and there's a bunch of microservices subscribing to it. So CloudWatch is one service that can accept multiple sources at once. So this is just multiple clients writing to the CloudWatch, which is triggering a Lambda. The most common use case for triggering a Lambda when a log comes in is transformation usually. Because what CloudWatch spits out, you wouldn't like it. So you want to make it prettier, more digestible. And then that's basically kicking off a publishing an SNS topic. And then these microservices are going to subscribe, or would have already subscribed to that topic, which is why they're getting that event. Logging. So when you put all these microservices together, and in our case where we have a legacy app and we're breaking it down into pieces, your request is bouncing through like a bunch of services everywhere. So how are you going to debug? It's like a debugging nightmare. What if something failed somewhere? I have to go through and check each one of those dead letter queues to see, hey, did it work? Oh, wait, yeah, it did. Oh, here, no, it didn't work. So what happened between that? So there's a bunch of things you can do on AWS. You have X-ray, you can turn on cloud tracing, but the one that worked, or CloudTrail, the one that worked best for us is we came up with a standard logging format. It starts with a correlation ID. So whichever service has initiated the request is going to create that correlation ID, and it is sent through every single hoop that it's bouncing around. So all I have to go is go to CloudWatch at this point, search on that correlation ID, and I'll see exactly where my request went and where it died and what didn't happen. So anyone trying to play with it, please keep that in mind. It's much easier to start with that than go back and fix it.
Can you go into detail of what that looks like? So you have a coordination ID, SMS, microservice. How do you enable that?
With the log format itself?
Yeah.
So log format, we have a correlation ID, which is just a request ID, a GUID. And then we usually have a timestamp, app ID, and then a JSON object that's app-defined metadata. Because we have grand plans. We've evaluated the log analyzers and log servers, and we came up with, for now, we're going to do our own centralized logging architecture. So we're just sending all our logs from CloudWatch to Elasticsearch in AWS. And AWS gives you Kibana dashboard that you can configure, which is really, really cool, by the way. If you haven't used it, try it out. It's very easy. So the app-defined metadata is anything that is relevant to the app. The custom data would come through that. Otherwise, the standard part will have a correlation ID. Oh, and a log type. Because the way we're using it, we're even using this concept with our servers, our EC2, our legacy apps. So when the log is coming from there, we wanted to know like what type of log is coming. Is that like a system log? Is that like a server log? Or is that application log? So. Just like any other tech, it's never one shoe fits all. Uh-oh. Sorry.
Challenges indeed.
Did you get it, or?
I don't want to break it.
That's why we can't have nice things around here.
You blaming that on me?
Well,
Well, I do talk with my hands, so thank you. So just like any other tech, comes with a lot of challenges. So please do your research before you connect all these fancy Lego pieces that AWS gives you. I already went over the example of DynamoDB. Because we're using legacy apps, we're using RDBMS. Like, we're using MySQL RDS, which is great. And my first instinct is, hey, let me just have my serverless talk to that. Do not do that unless it is absolutely necessary, because none of the other databases are designed to scale 100,000 requests or concurrent requests per second. Dynamo can. So try to use DynamoDB. As painful as it is, it's actually amazing when you get the use case right. Serverless is all about services, not connections. That's another reason why you wouldn't want to use a database, because database connections can get expensive. And that's just one example. There's like tons of issues we ran into. It's stateless. So where does the state go? You would exactly nowhere. So you'll have to maintain the state yourself. So you could use a database, you could use S3, but that comes with its own issues. Startup latency. So when you trigger your Lambda, there is a container that's starting somewhere, getting primed, booted, the code's getting downloaded, environment's being set up, and then it runs. So there is a lag. It's in milliseconds, but there's still a lag. Now, if add to that the fancy modules that we want to load, because let's say I want to process a PDF, then I need to create an image, I need to create a thumbnail, it's like a bunch of other pieces that I'm adding the latency every time I'm doing that. So understand your dependencies, make sure you only load the modules that are absolutely required. Do not connect to databases unless needed. I cannot iterate that. We ran into so many maximum connections issues because of that.
Aurora can handle it though.
Aurora serverless can, Aurora cannot.
Yeah, Aurora serverless.
Yes. Yeah, because they have the data API now, so now they can do that. And that came out like in the last 2 years, actually. It's still new, lack of tool support. It's gotten much better. We started 2 years ago. Right now, we're actually feeling really good about all of this. But it has ways to go. It still has ways to go. Hard to test. Why do we test? We test so we can to make sure our code actually runs, right? It runs locally, it will also run in production. There is no way we can mimic the environment, the cloud environment locally 100%. Serverless is not there yet. People have used Docker containers to mimic like a S3 or a SQS, but permissions is a whole different story. Once your code's live, good luck. I have not seen anybody get it correct the first time. I have not seen that. Limits. Anything you touch in AWS comes with a nice limit. There's two types of limits, soft limits and hard limits. Hard limits are the scary ones. You have to know that before you start because that is not negotiable at all. You're stuck. You have to re-architect for it. Soft limits, you can actually put a ticket in and request AWS to up the limit. This is actually worst of them all for us, our experience. Paradigm shift. It is a completely different way of thinking about architectures. So serverless is, it's just another toolkit in your microservices toolbox. So just trying to architect as a microservice is still a paradigm shift in itself, but it's pretty straightforward. You establish your bounded context, your separation of concerns, and your microservice does one thing and one thing really well, you're good to go. Add serverless to the mix, your asynchronous processing. So let's say I kicked off 100 Lambdas over here. A Lambda is kicking off another Lambda. But my AWS account has a limit of 1,500 Lambdas max. And I can kick them off like, 1,000 concurrently. So what about all these numbers, calculations? When am I hitting the limits? So I have to make sure my Lambda execution time is like a second or less, because otherwise I'm going to grow out of the concurrency concept. So just a lot of things to think about. Serverless is not a use case for everybody, or it's not a one solution fits all at all. Synchronous solutions, you can still use it for. It works great. But you're missing out on all the advantages, the benefits that come from the scaling and stuff. It comes from the asynchronous concept. Long-running tasks. Lambda has an execution limit of 15. Actually, that's not entirely true. It is a good fit for a long-running task if it only has to happen maybe once a day or once a week, very randomly. That's still a good use case because you can go back to the pattern where I showed you have the gigantic Lambda, you're splitting it up into Lambda workers. That is still a good use case for that. That's popular for ETL cases where you're extract, transforming, and loading the data, doing a bunch of analysis, because you still don't have to maintain the servers yourself. So that's still a good advantage. And complex compute with high memory requirements. Do not use it to process a 100 gig video file in a Lambda. Don't try that. Don't use it to process a 14 gigs PDF file. I'm using the number 14 because we have tried it. It works. Doesn't mean it's production ready or should be done. It was just a challenge one of our devs wanted to solve. It's actually pretty neat. If you understand the PDF spec, you just have to read that initial table so you know exactly where each page starts and ends. You can kick off a separate Lambda per page of your PDF and process it, but there is absolutely no reason to do that. In fact, do not do that. And if you have a use case where you need a response immediately, then maybe not a good use case for you. Resources. AWS documentation has everything you'll ever need, but for some reason, I cannot find anything I need. I hope none of there's no AWS people here, right? No, good. But these guys on Twitter, I follow them. They have blogs, they have their own articles, and they're really, really good. AWS Serverless, in fact, is AWS people. They actually use that Twitter handle and during their planning meetings, ask live, hey, what are the features you guys want? So if you're actually following them, you can contribute to their planning meeting directly. Final thoughts. If you're starting out, start small. Pick the correct use case. Think about the right pattern. Log extensively, otherwise you are screwed. Know your dependencies. Don't load all the modules just because we copy-pasted code from Stack Overflow. I have done that. And consider release management very carefully. Serverless comes with many benefits, but servers still have their place. It is not a replacement at all. Thank you. Any questions?
So, when you're architecting these things, how do you plan your costs?
We try to do, depending on what the task is actually, we try to do some analysis. We have a phase in development. Once we know that, okay, this is definitely something Infotech wants to do, we have an architecture planning phase where that's cost is one of the concerns, one of the things we keep in mind. But when we architect it out, we try to think through the cost and try to guess. Yeah.
You know, that issue, it's difficult to project what, money with what cost you're going to have. You can't test that until it's live. So, to get a ballpark figure, I don't think it's an easy thing to do.
Yeah, it really depends on the use case. And if you're just trying to get started and sounds like you're having a hard time convincing others from our previous conversation to try something like this, just try to start small. Something you can control, something you know is mega cheap. Like just using a Lambda, like Sean showed yesterday, for a month it's like 47 cents or something ridiculous like that. So start with something like that. Or control your traffic so it's not even running as much, and then try to get an estimate of, so let's say if I'm live and I'm getting these many requests, because you probably already have something live that you can compare to understand the load, right? So yeah, just try to calculate it that way. AWS does have a fancy calculator, but I don't know that it's ready for serverless cases yet. But it's mostly just pay for what you use for anything, actually. Yes.
I'm just curious, how much concern is there about vendor lock-in?
Once you're in, you're in. There is no, oh my God, I'm locked in.
It's like the mafia.
Yeah, but to answer your question, when we went to cloud, actually the reason we didn't go to cloud for the longest time is because we were concerned about the vendor lock-in. But I very quickly came around and realized that AWS's security team is bigger than my company, and they definitely know what they're doing. So once you actually digest that, you go all in. Yes?
What is the advantage that you actually found for logging use case by implementing it in AWS versus using like the ground solution?
So, other than Elasticsearch, you said? The ones we compared are Sumo Logic and Datadog, I think, the other one.
But why serverless?
Oh, why we're implementing our architecture, logging architecture serverless? That's because, so like I said earlier, right, we have a monolith and we're trying to break it out into pieces. And other legacy apps at various points, we had a business come through and say, hey, this is the next thing we want done, but the team itself wasn't ready. So what we ended up doing is borrowed a different team and we're like, hey, I know you know nothing about our app, but we need you to put this in place. So that's when we dove into serverless and we chose that as our use case.
So are you also able to then tap into like, say performance monitoring?
Yes, you could use, yes, you could use AWS X-Ray. It really, so that definitely helps with the performance stats because that was one of our concerns. But where I was going with my previous thing is, so that's how we started using serverless, and then we put a bunch of serverless apps in place, and centralized logging just seemed like the next step for us because all these legacy apps have user management dashboards, and that's basically showing user activity logs. So our way of doing that for serverless is by that logging architecture, which is why that's serverless. Yes?
You mentioned that you were pushing CloudWatch to L.
Yes.
You
We're not using
mentioned
the L,
Grand-
just EK.
Just EK.
Yes.
But grand plans, was that multi-tenant was the plan? Or multi-cloud?
We didn't get there yet. Right now, our plan just is, like I was saying, the dashboards for support. That Kibana is so powerful, and you can configure it to pretty much look like anything. So just using that as a front, and that's why we chose.
So it's a single pane of glass.
That's it. Yeah, all our logs from everywhere, legacy apps, serverless apps. We have almost 10 serverless apps right now. Everything's coming through this one place. Yes.
So when we say serverless, but the actual server still has its place. So does data protection plays any role in this, or if it does, then how?
What do you mean by data production?
In this is like backup, the backup of all my data, which is
Yes.
completely reliable on the serverless application.
So are you saying, are we doing that in serverless, or are you saying how does it compare with servers?
I'm just I want to know, like, does it has any role yet, or is it completely based on the S3 architecture, which has its own protection?
Well,
from AWS?
every Amazon service has its own way of backing up. Like Elasticsearch has you can set even like a log retention policy. It can clean up on its own, but ultimately all the backups everywhere are ending up on S3.
So basically that's something offered by AWS.
Yes, you can configure it so it does that. It's all ultimately snapshots and route to S3. But they do offer other services, like S3 has 3 variations. I totally don't remember the second one because that's relatively new. And the last one is Glacier. So it's completely inactive if you just want to archive your data. They don't charge you when you put it in. They do charge you when you're getting it out. Yeah. So different ways. Yes?
Did you mention you were converting a
Sorry.
legacy stack or monolith
Yes.
from AWS, just EC2 based over
Yep, to serverless.
How would the cost compare between the two stacks?
Since we're doing one piece at a time, we don't know yet, but we are not comparing cost for those cases because we're ultimately in construction industry, right? So we have an app that is focusing on localities. We have an app that's just focused on one phase of construction lifecycle. But whatever is happening at either like a DOT-based or a locality-based, ultimately the business logic is still the same, which means if I'm talking about plan sheets for DOTs, it's the exact same thing that's happening at the locality level, just much smaller. So for us, there's more value in pulling out the domain knowledge and pulling it out into microservice. So we did not do a cost comparison for that. But I have a feeling we're going to do that for our logging as soon as we go live. Elastic service is not cheap. Yes?
Are you, just want to understand with your package intro, is it a single SQS that manages all messaging? Or
Nope,
is it
you
one
have
for every
one
service?
per Lambda. You're configuring one per Lambda, which is why I keep saying log extensively. Yeah. It's serverless, everything's distributed. Yes.
I have 3 questions in 5 parts. So the lambdas, you talked a little bit about the functionality and logic in a lambda to do multiple things, or you kick off another lambda.
Right.
How do you how do you defer, or how do you figure out which one to do?
Actually, the most common way of doing that is kick off or put a message in a queue. So the queue on the insert to the queue kicks off another Lambda. This is one of the recommended ways of distributing a Lambda load into multiple Lambdas. Again, because keeping asynchronous and scalability in mind. A lot of people think kicking off one Lambda, kicking off another Lambda is actually a bad pattern. But I don't know. I'm yet to be proved wrong on that.
And if we do go more towards a multiple lambda or rapid sort of queue into multiple lambdas, you said that there was a limit. What happens when you hit that limit?
Concurrency limit, I think, is a hard limit if I remember it properly. Your Lambda's never getting kicked off. Your SQS is getting a message, or your dead letter queue is getting a message that invocation failed.
How do you test locally? Like how are you?
We right now are using Docker containers to set up locally and run tests. And we're in the process of evaluating different frameworks to see if it's gotten any better. So for example, there's something called Serverless framework. AWS, every service that they have can be cloud formed, and the service is called CloudFormation. So there's different frameworks that do that for you, so you don't have to worry about everything. And some of those frameworks come with a local environment that you can set up. Even those can only take you so far. Permissions are still not a 100% match anywhere.
Okay. And the last question is very selfish. I know you're not going to do a cost comparison, but Sean in the 47 cents.
Yes.
I personally would love to know if keeping this server base compared to going to the serverless, of what the cost options were to give it to management to show them real case scenarios of why you should go that route. Because it's difficult to say, okay, we're going to break off these 5 services out of this Docker, and you're only going to pay 38 cents, or let's say after a month of production, you spent $3,800, and the server was $4,200 just to keep it idle.
So if the use case is correct, that's an easy thing to calculate, relatively. It won't be accurate, but you can definitely convince anyone. Because when you're running a server, you are running, I'm assuming, a database. So the RDS, or again, I'm assuming Amazon Cloud. So if you're running an RDS, that is a solid chunk of cost right there.
Sure.
EC2, maybe $10 to $13 a month for running your actual server. RDS, maybe $100 or $200. If the use case is correct and it is intermittent, spiky traffic, it's very easy for you to make a case that there's no way. Because I'm guessing you have like Google Analytics or something that shows the traffic, right? So you can see your idle time when it's not being used and you're still paying for it.
Absolutely, and then you have the load balancing with the instances that expand, which jacks up all the costs and things
Yes.
like that. But it would be really nice to have that comparison of doing it on the serverless side of things. And just
Yeah, I mean, it won't be 100% accurate. You won't know until you go live. But because you know your load already, you can guess it. And you can make your case that, hey, you know what you're not paying for. Let's put it that way. So you remove that from your total cost.
right. That's a great point.
Yeah.
Is the learning curve reasonable, or do I need to hire DevOps?
Learning curve is reasonable. If you are a good learner. So we are a huge, we believe in the concept of DevOps a lot at Infotech. We have an ops team, a DevOps team. Right now, the major focus for them has been around legacy apps and CI/CD, automating that, taking that all the way to Docker containers, deploying that. Devs have been handling the deployment pipeline and everything for the serverless apps. So serverless architecture is going to help you bridge the gap even more. It's a different way of looking at it, which is why I said if you're open to learning, you'll see it and you'll understand it. Yeah.
The learning curve of starting from a brand new
Yes.
app is extremely amazing, but trying to take a legacy app from the serverless,
Completely different story.
that's when
How do you
you
even
get smart.
take this huge thing and break it into pieces? Business logic, I found, is a really good way to do that. Any other questions? Well, thanks again, guys, for coming to the last talk.